Hey, what's up guys, welcome back to this video. In this video we're going to solve this question, merge to sorted arrays. This is the problem statement. Given two sorted integer arrays nums1 and nums2, merge nums2 into nums1 as one sorted array. In the array nums1 we have m number of elements. The first m number of elements in this array is initialized and the rest we have some placeholder. So we can merge this array into this array because we have enough space in this array. So we have in this array m number of elements from starting index to the index m-1, and for the rest element we have some placeholder. Here we have note the number of elements initialized in nums1 and nums2 are m and n respectively. You may assume that nums1 has enough space size that is equal to m plus n to hold additional elements from nums2. Because array size is fixed, we cannot change array size during runtime. And the constraint to this problem is that we cannot create a new array. We have to merge nums2 array into nums1 as one sorted array. And we have to solve this problem in linear time complexity. We have to solve this problem in linear time complexity and in constant space complexity. Now let's see how we can solve this problem. Before that, first let's see some example. For example, if you're given this array and this array, this is nums1 array and this is nums2 array. We have to merge this array into this nums1 array, and in this array we have initialized 3 elements from first index to the index m-1. So here we have initialized this 3 element in this array, and here we have placeholder. Now we have to merge this array into this array, and the array should be in sorted order. And here we have 3 elements in this array. If we merge and sort this array into this array, then we get this array. Okay, this is nums1 array. We're not creating a new array. We're solving this problem in Fletch. Now how we can solve this problem? Now let me show you how we can solve this problem. For sake of understanding, let's assume we're given this array. This is nums1 array, and this array, this is nums2 array. In this nums1 array we have initialized 3 elements 1, 2 and 3 from index 0 to index m-1, and in this array we have 3 elements, so n equals to 3. We have to merge this array into this array, and this array must be in sorted order. Now how we can solve this problem? To solve this problem we're going to use 2 pointers. P1 pointer will point to the last initialized element in this array. We can get the index of this element by using the formula P1 equals to m-1. So P1 equals to m-1. And we're going to initialize another pointer P2 that will point to this element. This is the last element in this array, and we can access the index of this element by using the formula P2 equals to n-1. And our current element is this element. Okay, so this is our current element. Now what we're going to do, we're going to check the value at P1 pointer and at P2 pointer. We see 6 is greater than 3. So we're going to take the maximum value of these two and we're going to update the value at current. So this is our current element because we're traversing from right to left. We'll see how to do this when we will go through pseudocode. Here we're going to update this value with 6, the value of P2 pointer. So let's update this value with 6. Now we're going to move P2 pointer to the left since we taken the value from this cell. So let's move P2 to the left. So P2 will point here. Here we're taking the maximum value because the array should be in ascending order. So the rightmost element should be maximum element. Now here we have to move this I to the left because our current element changed to this element. So this is our current element. Now we're going to check this 2 value. We see 5 is greater than 3, so we're going to update this value with 5. So let's update this value with 5. Let's move P2 to the left since we have taken the value from this cell. We're going to move P2 right over here, and this is our current element. So let's move I right over here. Now we're going to compare these two values. We see 3 is greater than 2, so we'll take this value and we'll update the value at this index. Here, let's update this value with 3. And let's move P1 to the left. Now our current element is this element. So I points to this element. Now we're going to compare these two values, 2 and 2. We see the two values are equal. So we're going to take from this cell here. If they're equal, we'll take from this cell. So let's take this value and let's update this value 3 right over here. So here we're going to update with 2. Now let's move P1 to the left. P1 points right over here. Now this is our current element. Now we see that 1 is less than 2, so we'll take the value from this cell and we're going to update the value at the current cell. So let's update this value with 2. Now we're going to move P2 to the left. Here we have no element on the left, so we're going to set P2 to negative infinity. The value negative infinity, okay? Since we have no element on the left of 2. So P2 is points to the negative infinity. That means the minimum integer we can store in 32 bits. And we're going to move our current to this because this is our current element. Now we're going to check P1 and P2. We see P2 is the minimum element we can store in 32 bits. So what we're going to do, we're going to update the value at current with this value 1. So let's update this value with 1. Now we see that this array is sorted. We have merged this sorted array into this array in linear time and in constant space complexity. Hope you've understood how to solve this question. Now let's see the pseudocode. Here we have this function merge. This function takes 4 parameters, nums1 array, and m is the number of initialized elements in nums1 array. Then we have here nums2 and n is the number of elements we have in nums2 array. Then we have here 2 pointer p1 and p2. Here p1 pointer points to the last initialized elements in nums1 array and p2 pointer points to the last elements in nums2 array. Then we're running a loop from the last element to the first element. Here we have e1. e1 is the element where p1 pointer points to in nums1 array. And here we have e2. e2 is the element where p2 pointer points to in the nums2 array. If p1 is greater than or equals to 0, then we're getting the value from p1 pointer where p1 pointer points to in nums1 array. If not, we're returning the minimum integer we can store in 32 bits. I'm considering this is as minus infinite. Here, if p2 pointer is greater than or equals to 0, then we're getting the value from p2 pointer where p2 pointer points to nums2 array. If not, we're returning the minimum integer we can store in 32 bits. If e1 is greater than or equals to e2, then we're updating our current element with e1. Then we're moving p1 to the left. Else, we're updating the current element with e2 and we're moving p2 to the left. This is the algorithm to solve this problem. Hope you've understood how this algorithms actually works. For better understanding, let's check. Let me go through the examples once more time. Here we're given this array and this array. And m equals to 3, n equals to 3. So p1 pointer points to this element and p2 pointer points to this element. Here we have this statement m minus 1 and n minus 1. And this is our current element. We see p2 is points to the element that is maximum. So let's update this value with 6. So let's move p2 to the left. p2 point right over here. Our current element is this element. And here we see that 5 is greater than 3. So let's update this element, this current element with 5. Now let's move p2 to the left. So p2 will point to this element. Then we're going to check this 2 element. We see 3 is greater than. So let's update this current element. This is our current element. So let's update this element with 3. Let's move p1 to the left. p1 points right over here. And this is our current element. We see 2 and 2. and they're equal. So if they're equal, we'll update the value from this cell. So let's update this value with 2. Here you can take the value from here, that means from this array, but we're taking from this array. Now we're gonna move P1 to the left. This is our current element. We see 2 is greater than 1, so let's update this element with 2. Then P2 points to -infinite, okay? And here, this is the value, okay, where P2 pointer points to now. We can consider that, okay? So here, -infinite. Now we see that 1 is greater than -infinite, so we'll update this value 1 with 1. Now we're done. We traversed this array from right to left once, and we have solved this problem. This is how we can solve this problem. Hope you have understood how to solve this problem. This solution will take big O in time complexity and big O on space complexity. Hope you have understood how to solve this problem. If you have any issue understanding this video explanation, let us know. Thanks for watching this video. I will see you in the next video.